All right, what if something's not a perfect square? There's my intro. That's for one of my students who said I need an intro all the time. So this section, 2.4, what this is about is finding a process for completing the square. In the previous section, we talked about how to find out if something is a perfect square. Here, we're going to find a process that works for all functions. We're going to adapt and use diagrams for a more efficient completion of the square. And we're going to look at how we can complete a square if there's more than one a value. So how do we do that? So that's the focus of what's going on here. So if we look, question number 1, aside from all the verbiage there, it talks about what if a customer comes in with 4 blocks of the basic size? Well, think about it. The basic size is this one right here. What if they come in with 4 of those? How do I draw a diagram to express that? Well, if this is the basic size x by x, how many of those should I have? Think about it. I should have 4 of those. There's what a diagram of that looks like. Plain and simple, right? Now we move on. Again, they're using the models here. So question number 2. Dumb smartboard here. Yes, kind of oxymoron. One of the customer service representatives find an envelope that contains blocks pictured below. Write the order that shows 2 equivalent equations for the area. I'm gonna show a lot actually, but think about this. Let's go ahead and find the area of each individual block, like we did way back when. So we have x squared. All of my rectangles are x's, and all of my one little squares are 1 units. Now I'm not going to go ahead and fill this other one in because it's all the same thing. So what do you have here? You have one equation of length times width, which should be x plus 3 times x plus 3, right? So that would be x plus 3 squared. But how many of these diagrams do you have? You have 2 of them, so times everything by 2. There's one expression. The second expression would be actually physically writing out what you would have. I know I have 2 of the same thing, so I have 2x squareds. I have plus 6x plus 9. I have 2 of those, so those are 2 equivalent equations. We could say, or, and I'm throwing this out there because you're going to see this, what if I distributed the 2? I'd have 2x squared plus 12x plus 18. All of those are equivalent equations. All right? Try number 3. Try 3 on your own. All right? So pause it, try 3 on your own, draw a diagram, draw a couple of questions, and come back, and we'll see you in 4. All right, number 4. What if customer service receives an order for 3 square blocks with both dimensions increased by 2? I can draw a equation based on what they've told me without drawing a model. What if they receive an order for 3 square blocks with dimensions increased by 2 inches? Well, think about it. That's dimensions increased by 2. X plus 2 squared. And how many of those perfect squares do I have? 3. So there's one equation. There would be one equation. Or what if I go with another one? 3 times, and now just x plus 2 squared. So x squared plus, multiply these 2, x times 2, and double it, 4x plus, and square the last term 4. There's one way to write that. And then we're going to go with an or. You can get 3x squared plus 12x plus 12. There's a third way to write it. Now if you need to, model that. Model what that would be. All right? Now number 5. Here's where it gets a little bit tricky. All right? So we go with the dog scenario again, where the doggy ate my homework. They chewed off the end. Well, if you notice in the previous 2 questions that I did, I kind of helped set you up with this. In the fact that I need to be able to write an equivalent equation for this model. Well, think about the model. I'm going to break this up and find out what each of my separate models should be, because I know this a value here tells me how many models I should have. So if I take that out, what am I left with? I'm left with x squared plus 4x. So I need to find out what value here is going to make that a perfect square. Just one of them. Just one of them. Well, in order to find out what one of them would be, again, I'm going to have 2 of these models. Think of this right here. This 4x, I have to divide that equally in half. 2 x's go to one side, 2 x's go to the other. So there's 2 on one side, there's 2 on the other. It's not a perfect square, so fill in the model. Well, what's it going to be? It's going to be 4. And how did we get that? From the previous lesson, we decided Okay, we came up with the rule, 4 divided by 2 squared equals 2 squared, which is 4. That's another way we found out how to do it. Rather than draw a model every time, this was the shortcut, right? So that 4 is what's going to make it a perfect square. But 2 times 4 is 8, so this should be plus 8. Right? That's what should have been. Right? Think you can do the next one? Well, you should be able to. Divide out the 3, and notice I took the 2 out of both terms. So I've got to take the 3 out of both terms. So I get x squared plus 8x plus what is going to make that a perfect square? 8 divided by 2 squared. 8 divided by 2 is 4. 4 squared is 16. So that's what that's going to be. All right, now, and again, I know this is kind of a long video, but there's a lot going on here. So I apologize for that. Right? If you need to, pause and rewind. Now, here's a real mess. Right? This is going to take a little bit of explaining to do. Right? They received an order for 2x squared plus 12x plus 13. Help them figure out an equivalent expression for the area using the diagram. All right? So I want an equivalent expression, and it's using the diagram. Well, I have 2x squareds here. Half of these x's would have to go to one of those x squared. So 1, 2, 3, 4, 5, 6, and I'll just tell you there's 12 total. So half of these have to go to one, the other half have to go to the other. But how many of these little single unit squares belong with each of the x's? Well, if you're not sure, figure it out. What would I have increased each side by? X plus 3, x plus 3. If you said by 3, you would be correct. Half of these 6's have to go to one side of one diagram, and half have to go to the other. So it would be 1, 2, 3, and then 3 down here. And what is this little section that I fill in here? How many is in there? That should be a 3 by 3 or a 9. We'll count up how many do I have. 1, 2, you should count them up, and you should see that I have 13. That means that 5 of these will go to another block. Okay, so let's just draw the diagram here, and we'll figure it out. There's 9 there. Here's that's a horrible square. It looks more like a rectangle. Here's my other square. So I get 3, 2, 3, 1, 2, 3. Now this should be a perfect square, but I don't have enough single unit blocks. I only have 5 blocks left. So this is what I have if I draw my diagram. How many blocks am I short? How many blocks am I short of being a perfect square? I'm going to be, what? I'm going to be this many short, right? That means I'm going to be 1, 2, 3, 4 blocks short. I'm 4 short of perfect. That will come into play into my equation that I write. So it says plus 13. So here's how I'm going to do this. I'm going to take, and I'll just use this equation right here. I'm going to divide the 2 out of the first 2 terms, because I know it's not perfect. If it was perfect, it would be 18. It's not 18, it's 13. So since it's not perfect, I'm going to take the 2 out of the first 2 terms, so x squared plus 6x plus something is going to be perfect, and then I have that 13 over there. Okay, so what's going to make these perfect? Well, we should know it should be 9, right? How are we getting that? Well, look at this chunk right here. I'm going to take 6 divided by 2 and square it to get what makes it perfect. 3 squared equals 9. Okay, well, remember we were 4 short. So I have the 13 over here. I got to account for that. So now I know that I can rewrite this as 2x plus 3 squared. Right? And I have that 13 over there. Remember, I was 4 short of perfect, so that's minus 4 right there. There's my equivalent equation for writing those models. All right? I'm 4 short. If I had 18, all of this would have been perfect, but it's not. Right? We'll talk about how to kind of deal with this in the future coming up here. Try 7 on your own. Ask questions if you need to. Now is where we get to deal with this. Here's where we come up with the idea on how to mess with this and only have you do a couple of these problems. We'll probably finish the rest on our own. Is this going to be perfect? All right? If it's not, we need to be able to adjust it. So if it's going to be perfect, all right, a's value is 1. If it's going to be perfect, then when I divide the b value by 2 and square it, I should get the same number here. So 6 divided by 2 is 3. 3 squared is equal to 9. 9 is not 13, so it's not a perfect square. Okay, so what do I do? Well, here's what you do. You divide a from the first two terms, so you get x squared plus 6x plus something that makes this portion perfect, and then you have the plus 13. So here's what I have to do. If I am doing something to one side of an equation, I have to do the same thing to the other. This process is a little bit shorter than that. What I'm going to show you is whatever you add in parentheses, you have to subtract out of it. So I'm adding 9 to make this perfect, so I subtract 9 out of it. What does that give me? Well, it gives me a perfect square here in parentheses, so x plus 3 squared. Remember, the divide by 2 gives me my second term's value. And then what's 13 minus 9? 13 minus 9 should be plus 5, right? No, 4. That should be the same as the previous problem that we just did. Okay, so there's how you complete the square. Let's do one more. Again, go through the process. I'm going to separate the a from the first two terms. Well, actually, let's pick a different one. Let's pick one where a is not 1. Let's pick d. All right. So here, I'm going to separate the 2 from the first two terms. I have two models. So I'm going to divide 2a. So 2, and I could separate everything. I could do that. But let's separate it from just the first 2. So x squared plus, because I'm actually going to do more work if I don't do it that way. So 4x plus something, and then I have plus 14 out here. Well, what's going to make this one model a perfect square? 4 divided by 2 squared, which is equal to 2 squared, which is 4. So 4 goes in there. If I'm adding 4 in parentheses, I have to subtract 4 outside. So 2, and whatever makes this a perfect square, which would be x plus 2 squared plus 10. All right? So basically you have perfect squares, either plus some or minus some. All right? As we saw over here, we have plus 4, we have plus 4. And then it wants you to go ahead and generalize the process. This is the last thing here, all right? And I want to get my notes because I want to make sure I'm correct here. So generalize the process for completing the square. We'll go through more of this in class if you have questions, and we'll see it over and over and over and over again, all right? But follow the process. I tried to shorten these steps up as much as possible. Step number 1 is divide a from the first two terms. And separate C. Okay, so you're going to do that. That's exactly what we did. The second thing, we're going to take half of B. And square it. Then add in parentheses and subtract out. Okay? Believe it or not, this is all a shortcut. This is all, like I'm writing these notes really short. And then the third step and the last step is to write A in front of parentheses as a product of squares. And I'll give you an example of what that means. Okay? Followed by the C term, or the new C term. So it looks something like this. A parentheses x plus, and I'll just use 2x plus C. So it looks something like that. Okay, here's your new A value, here's your new C value. Right? It's going to take us some time to go through and get through those. Right? Do not worry about doing F. We will do F in class as a whole. Right? So challenge yourself with a couple of those and ask questions as you need to. I know this is going to be difficult, but it's going to be more difficult if you don't ask questions.